Alright class, today we're going to look at solving radical equations. Big important property to note, if you have two things that are equal, like a base that are equal, then you can either A, raise both sides to the same power, or if you get it looking like this, then you can state that the powers are equal. So, let's look at some problems. Here's what you got to do. When using the power property of equality to solve equations, you have to isolate the root term, or the power term. N is the fraction or integer value. So for number 1, n is root 3, or so it's, I guess, 1/3, x to the 1/3. So we want to isolate that. So we just move over the 3 by adding 3 over. Now at this stage, we know these are equal, which means that we can do the same thing to both sides. And to cancel out a 1/3, we raise both sides to the third power. So I get x is equal to 27. Now always check your answers to make sure the solutions work. 27, if you put a 27 in there, the third root of 27 is 3, minus 3 is 0. So since it works, I'm putting that in my set notation. Alright, number 2, you move the 4 over, divide by -1, and now you can raise both sides to the fourth power. Now you have to be careful. It's okay so far what we've been doing, but you have to be careful if you raise something to a fraction, because then you're rooting it, and you have to think about if it's going to be plus or minus versus just one solution. But in this case, we're just raising it to not a fractional exponent. So you get x is equal to 256. So if you plug that in, the fourth root of 256 is 4, and 4 minus 4 is 0, so that is a solution. And I think this is the one I'm talking about here with the rooting. First thing you should do though is get rid of the 2. So x to the 3/2 equals 343. So the next thing you do is, to get rid of the 3/2, you have to raise it to the reciprocal fraction. We're raising it to the 2/3. And that'll get rid of it, because when you multiply that, that'll be x to the first. And here's where you have to be careful. This is your root, right? If that's your root, that's an odd root, so we're okay. We have a positive here, and we're only going to get one solution. And then, so basically they're saying root this and then square it. Okay? Now you can just type this in your calculator first to see if you get a nice answer. And sure enough, if you type 343 to the 2/3, you get 49. So you don't have to do all the breakdown stuff if the number is nice. So check it in your calculator first. Alright, so we have 49, and then you can just plug 49 back in. You take the square root of 49 and then raise it to the third. That's 343 times 2 is 686. So 49 is fine as well. Here you have to be careful. First we're going to divide. So 243 divided by 3 is 81. Then we're going to raise it to the 3/4 power. Again, what that means, I'm going to just show you over here. That means that we're doing this. That's raising it to the 3/4 power. We're taking the fourth root and cubing it. When you take an even root, this is even, you need, like a square root, if you take the square root of both sides when you're solving, you need a plus or minus in front of your answer. So you type this into your calculator, and you get x is equal to plus or minus 27. When your calculator will spit that out when you do 81 to the 3/4. It won't give you the plus or minus. You have to remember to do that because it was an even root. Now you can check both answers. So put 27 in parentheses to the 4/3 times 3, and negative 27. When you raise that to the fourth, the negative will go away. You root it, or by 3, third root, and then times 3, and you do get 243 for both answers. So both are solutions. Alright, so now we're going the other way. A lot of these are starting out in radical form. You want to isolate the radical. So we have to move the 1 over. 3 plus 1 is 4. Now that the radical is isolated, we do what we need to do to undo it. This is a square root, so we square both sides. We get 2x plus 4 is equal to 16. 2x is equal to 12. and x is equal to 6. Let's just double check real quick. 2 times 6 is 12, plus 4 is 16. The square root of 16 is 4. 4 minus 1 is 3. So 6 is a good answer. Alright, so with problems where you have x's under the root and not under the root, generally you still want to isolate the roots. So this is isolated already, so we have to square both sides. Here's where you have to be careful. When you square both sides, you're not just squaring the x and the 5. Remember, you're foiling this. And when you square that, you just undo it. So over here we get x squared minus 10x plus 25 is equal to negative 2x plus 10. Move the 2 over and the 10 over because it's a quadratic. X squared, that's a plus 2, so minus 8x plus 15 equals 0. Alright, so we get x minus 5 when you factor, and x minus 3 equals 0. And both of these are x equals 5 and x equals 3. So here's where you have to check these. Okay? If I put a 5 in, I get 5 minus 5 is 0 on this side, so this thing has to equal 0. Negative 2 times 5 is negative 10 plus 10 is 0. Square root of 0 is 0. So this one checks out. Let's look at 3. I put a 3 in on this side. I get negative 6 plus 10, which is positive 4. The square root of positive 4 is 2. If I put a 3 on this side, notice what happens. I have 3 minus 5. 3 minus 5 is negative 2. So negative 2 does not equal 2. So this is actually an extraneous solution that was created because we squared both sides. So I'm going to say that one's a no. So set notation then is the solutions that are correct we put in our bracket, and the solutions that are not correct we put in parentheses. Okay. Last one for the day. Again, move the number over first because you want to isolate the radical. So we have an x plus 2 over here. Square both sides because we can raise both sides of the same power if we say that these are equal. So FOIL this and you get x squared plus 2x, and 2x is 4x plus 4 equals 2x plus 28. Move everything to the left. X squared plus 2x minus 24 equals 0. Now we factor. 6 and 4 plus 6 minus 4. We get x equals negative 6 and x equals 4. Double check both into the original. If I put a 4 in, 4 times 2 is 8, plus 28 is 36. The square root of 36 is 6 minus 2 is 4, and that would be a 4. So the 4 checks out. Negative 6. Right away, you should be able to see that this probably doesn't work. Let's see, though. Negative 6 times 2 is negative 12. So plus 28, you get a 16 here, right? And the square root of 16 is 4. 4 minus 2 is 2. 2 does not equal if we put in a negative 6 for x. So negative 6 is not a solution. So my final answer would say that 4 is a solution and negative 6 is not. So always remember to check for your extraneous solutions, or else you're going to get some points off. Okay, always check your answers. You'll have time. Alright, that's it. Solving with powers.